Hello students, welcome to Sridhar Sir chemistry class. Okay, now in electrochemistry, the next video itself is electrochemical series. So many important questions are there in electrochemical series. So what is electrochemical series and what are the applications of electrochemical series? Let us see now. So see here, you know that electrode potentials are measured using standard hydrogen electrode or secondary calomel electrode. Some of that electrodes having negative electrode potential and some of the electrodes are having positive electrode potential. So like that here, if we arrange all the electrodes in the increasing order of their electrode potential values, that arrangement is known as which one here? Electrochemical series. I repeat again here, the arrangement of electrodes in the order of increasing standard reduction potential values is known as which one here? That electrochemical series. Okay, now let us see here what are that electrodes arranged here. I will give some important electrodes in that series. The first one, the top of the electrochemical series occupied by lithium, its value of potential is minus 3.05 volts. And like that, if you come here, sodium electrode, its value minus 2.741 volts. And after that, zinc electrode, Zn plus 2 by Zn minus 0.762 volts. And then nickel plus 2 by nickel minus 0.250 volts. And Sn plus 2 by Sn minus 0.140 volts. H2, that means H2 by H plus, its value we know that assumed to be 0. And Cl2, okay, now come to this one, Cl2 by Cl minus plus 1.360 volts. And before to that we can write another one also here. Of course here somewhat less place. Okay, copper plus 2 by copper plus 0.340 volts. And Ag plus by Ag plus 1 point, okay, what is that, plus 0.80 volts. Cl2 by Cl minus plus 1.360 volts. And finally fluorine by F minus plus 2.87 volts. So these are the, okay, I will write here copper plus 2 by copper and silver plus by silver. And then here Cl2 by Cl minus, F2 by F minus. Okay, first let us see which is present at the top and at the bottom. Okay, now in this series, top position occupied by which electrode? Lithium electrode. And bottom position occupied by fluorine electrode. So this is the increasing order of standard reduction potentials of different electrodes. Of course, some of that electrodes we have not given here. Some important electrodes I have given. So what are the different type of questions we get from electrochemical series? So let us see what are the type of questions. The first one, the electrode which occupies top of the electrochemical series. So what is that? Lithium electrode occupies top of the electrochemical series. Bottom position occupied by fluorine electrode. Then another one. If you observe this lithium electrode, it is having more negative electrode potential value. More negative, or we can say less electrode potential value. In any way we can understand. Lithium electrode is having more negative E0 value, or simply we say less E0 value. And if you come to fluorine electrode, it is having high positive E0 value, or simply highest E0 value. So we have to compare that negative potential with positive potential, which act as oxidizing agent or which act as reducing agent. Let us check here. If you observe this lithium electrode, or the electrodes having less E0 value, or which are having more negative E0 value, they act as reducing agents and themselves they undergo oxidation. How you can say this one? You may get the doubts. Sir, how you can say this? How you are saying like this? See, let us see here. If you observe this lithium, we know that lithium atomic number is 3. Its configuration written as helium 2s1. Its configuration written as helium 2s1. But lithium always try to lose one electron to get helium configuration. That means here lithium loses electron to convert into lithium plus. We know that loss of electrons is oxidation. We have to remember like this. Leo Ger. That means Leo will shout like Ger. That means Leo means what? Loss of electrons oxidation, gain of electrons reduction. So here as lithium losing electrons, we say that lithium undergoing oxidation. If any substance itself undergoing oxidation means this act as a reducing agent. Why? The electron lost by the lithium, this electron gained by the fluorine and changes into F minus. So here fluorine gaining electrons. As we said that gain of electrons reduction. That means lithium by losing electron reduces fluorine. So that means here lithium itself undergoing oxidation but reduces fluorine. And again we can say like this. Fluorine itself undergoing reduction but oxidizes lithium. But oxidizes lithium. So from these two examples, what we come to know here, lithium is always try to lose one electron and act as a reducing agent. Of course, itself it undergoes oxidation. So what is the general conclusion here? The electrodes with more negative E0 value or less E0 value, they undergoes oxidation themselves but act as reducing agents. So oxidation takes place means these can act as anode. The electrode which is having less E0 value act as which one? Anode. And it can act as a reducing agent. That we have to remember. Now come to this fluorine. As we observed in this reaction, fluorine is tend to undergo reduction because it is just one electron short to get neon octet configuration. So fluorine always tend to undergo reduction, and itself it act as oxidizing agent. But here if you observe, fluorine is having highest E0 value. So what is the generalization now? The electrode which is having highest E0 value, that undergoes reduction itself and acts as oxidizing agent. So two conclusions I want to give here. The electrode with least E0 value undergoes oxidation itself, acts as reducing agent, and the electrode with highest E0 value undergoes reduction itself and acts as oxidizing agent. So now let us go for the different questions we come across from this, which one electrochemical series. So as just indicated, according to this description, lithium act as strong reducing agent and fluorine acts as strong oxidizing agent. So the electrode or the metal which reduces all the metal ions means here which one, that lithium electrode. Lithium electrode reduces all the metal ions and non-metals present below to it. Of course, all are present below to it. So, lithium can reduce all the metal ions and non-metals. Then, which can be reduced by all other electrodes means nothing but fluorine. Fluorine can be reduced by all other metal electrodes and non-metal electrodes. Okay, then this is in reverse direction, we can say. What is that? Fluorine can oxidize all the metals and non-metals, and lithium is oxidized by all the metals and non-metals. Okay, then what are the different questions we are going to see from this? Okay, see here, they give the question like this: E naught of Zn plus 2 by Zn minus 0.762 volts, and E naught copper plus 2 by copper plus 0.34 volts. Now, four different options I give here. We have to answer which is correct. First one is zinc reduces copper. Zinc reduces copper. And second option is here, zinc reduces copper plus 2. Zinc reduces copper plus 2. And third option is here, zinc oxidizes copper. Now fourth option is here, Zn plus 2 oxidizes copper plus 2. Like that, four different options they give. But most of the students will take the first option only. Just they can say, sir, zinc is having least E0 value, copper is having highest E0 value. So zinc reduces copper, but not that is correct. That is not correct here. But that is not correct. What is correct? Why there is a wrong here? Now see here. Zinc not reduces copper. Zinc reduces copper plus 2 to copper. Zinc reduces copper plus 2 to copper. So this is not the correct option. Which is now correct option? Zinc reduces copper plus 2. And again, this one also they give like this. Lucky. So now here a small disturbance. Okay, now here zinc. Okay, I give another option here for you. What is that option? See here. The first option is here. The first option is copper plus 2 oxidizes zinc plus 2. Second option, copper oxidizes zinc. Third option, copper plus 2 oxidizes zinc. Fourth option, of course, you can take none. So which we have to tell now? Here we can see that what we say that here zinc reduced copper plus 2 we said already. That means what is the right answer? Copper oxidizes zinc, that is not the correct. Here what we have to say, copper plus 2 oxidizes zinc. Don't say zinc plus 2 also. Copper plus 2 oxidizes zinc. Okay, in general, by writing that equation we come to know that clarity here. What is the equation? Zinc plus copper plus 2 gives Zn plus 2 plus copper. This reaction indicating what here? Zinc reduces copper plus 2 to copper, and itself zinc is undergoing oxidation. So like that here, the electrode having less E0 value that act as a reducing agent, itself it undergoes oxidation, and the electrode which is having highest E0 value that can act as which one here, oxidizing agent, itself it undergoes reduction. So now here, whenever the electrodes having negative E0 value connected with hydrogen electrode, they undergoes oxidation and act as anode. When electrodes having more E0 value connected with hydrogen electrode, they undergoes reduction and acts as which one means cathode. So we have to remember this point here. If any two electrodes they have given and E0 values are provided, means the electrode having less E0 value acts as anode, and the electrode having highest E0 value acts as cathode. And some other different questions also there. Let us see what are the questions here. So one question I will give here. Zinc sulfate. Zinc sulfate is stored in copper vessel. The question is here, is zinc sulfate can be stored in a copper vessel or not? Is zinc sulfate can be stored in a copper vessel or not? Yes, we can store it, because zinc here present in zinc plus 2 state. That means if you see the reaction, if any possibility, copper is here, Zn present in Zn plus 2 state, and copper plus 2 plus zinc. This reaction is not possible, because zinc reduces copper plus 2, but not copper. Copper does not reduces Zn plus 2. So we can say that zinc sulfate can be stored in a copper vessel. The same question they give in another way. If you want to stir the zinc sulfate solution, is it better to use a spoon made up of with copper? Is it possible to stir zinc sulfate solution with a spoon made up of with copper? Yes, that is possible, because when we stir that zinc sulfate solution with a spoon of copper, no reaction takes place, so nothing will happen. So that is successfully we can done that process. But in the reverse way, if they have given, what is that? Is copper sulfate can be stored in a zinc vessel. So this is not possible. Why? Because Here zinc reduces copper sulfate solution to zinc sulfate and copper are formed here. That means after some time the copper sulfate taken in the zinc vessel that has been changed into zinc sulfate. So it is not possible to store copper sulfate in a zinc vessel, and also it is not possible to stir that copper sulfate solution with zinc spoon or a spoon made up of with zinc. So like that they give the different questions regarding this electrochemical series. So the final conclusion is here. In the electrochemical series, what are the conclusions we have to take here means, first one, the electrode with least E naught value or highest negative E naught value that itself undergoes oxidation and acts as a reducing agent, and the electrode having highest positive E naught value or highest E naught value that acts as a oxidizing agent and itself it undergoes reduction. And in construction of a galvanic cell, the electrode with least E naught value should be taken as anode, and that with highest E naught value should be taken as cathode. So these are the different conclusions we have to get from which one, this electrochemical series. Okay, in our next video we will see what is the construction of galvanic cell, how to write the cell reaction, and how to represent that galvanic cell, writing cell reaction and calculation of E naught cell. Okay, bye.